This Hi, welcome back in this second part of descriptive, exploratory data analytics. Right, with we're talking about student placement exam here. I want to go down into much more details. Going deeper into the data sets. Exploring further. Digging deeper. Right, that's where we stopped earlier in the previous video. Right. So what I want to do here is let me create a new chunk. Right, create another chunk here. Great. So what I want to do here, first of all, is to look at quantile. The quantile here, these are percentages that allows you to see like okay, like when you look at this. So let's look at the given score, like SAT for example, PSATM, right? When you look at the first quantile, which is 56, that's the 25% of the student. The lower, the bottom 25% of student, the highest they score is 56, right? When you come to the third quantile, which is 66, that's the bottom 75%. Like when you take all the students, like the lower, from the lowest score coming up to the ladder, yeah, 75% of them, that's what they score here, right? 66. And 80 here, they score 80. That's the highest score actually, max, right? And the lowest is 43. Now the quantile that we're going to use here to look at, let's say we want to look at like the 90th quantile, or the 90th percentile, or the 80th percentile, or whatever. It tells you like 90%, of the student, the top nine, 90th, like the score, the highest score, by the top 90%, of the student. So, and the code that you use here, to look at this percentile is quantile. So the quantile helps you look at the percentile. So you just type in quantile. So that's the function that you use to look at percentile. And inside you can see you have x, and then you have dot. The x is simply telling you the score that you wanna, the variable that you wanna look at, right? So let's say I want to look at this very one, SATM, right? PSATM, and then I want to look at so let's put PSATM, right? And I want to look at the 90th percentile. 90th percentile, you want to put 90th percentile because it's a percentage, right? 90% is 0.9. So we then put here 0.9, and we can run this code. And I kind of feel like it doesn't recognize PSATM, right? Because we needed to attach it. We did not attach. If I attach the variable, we wouldn't have this problem. But I failed to attach it. And so if you want to use the PSATM, I have to use math placement, right? Math placement, yeah, and then I use $sign. Okay, cool. Now we can run this code and look at the 90th percentile, which is 71. 71 is the highest score by 90% of the student. So when you take 90% of the student, the highest score, within this 90% of the student is 71. That's the highest score. Now, when we can also try to look at like the 80th percentile, so that we can compare with the result that we've obtained with our summary statistics. So I can look at the 80th percentile here instead of 90. You can run this line of code. This is 67, and that's what we have here for the PSATM. Let me scroll this down right here. See, now we do not even have, it's the third quantile. This is 75%. So let me change this to 75%, and we can compare with the summary statistic 66. That's what we have here. When you look at PSATM, the third quantile is right here, 66, right? So that's why it tells you that 75%, that's the highest score by 75% of the student. 75, but absolutely, if you want to look at the highest score by all the students, which is 80, you just put one there, right? It's 100%, and then you're gonna have 80. You see, so the top 99% of the student, you can look at that as well. That's 75.95. That's the highest score on PSATM, and we can switch that, right? Instead of looking at PSATM, I can change this to SAT. All right, this variable right here, because when you look at the statistic, we have SATM right here. So I want to use SATM and look at the The 90th percentile, right, which is 0.9, that's 72. So that's the highest score by the top 90% of the student, 72. And so that's the, it's very interesting, this function, this quantile function actually, it can be very, very helpful, when you have a class of students and you are trying to retrieve, some set of information as regarding scores, like top 80, like top 90, top whatever, it's very helpful. um yeah, so I thought I should explore, this function. Hopefully this help. What else can we explore? Because this is exploratory data analytics anyway, so I just want to go through anything that comes on my mind, right? We are exploring, so let's keep on exploring. Let me see, what can we come up with again? Okay, cool. Let's look at actually correlation, right? Let's look at the relationship between between like the rank, okay, between the student, the rank. We have the rank here, yes, it's between the student rank and the placement score, because the data is here anyway. I view the data, right? So I want to look at the relationship between the rank. Where is the rank here? Right here. Okay, when someone score, like this student for example, his rank is the first rank, this is 47th, is 139th, and so on, right? And then we have their placement score, right? This is the score, like the student that the first rank, student, his placement score was 23. The 47th, his placement was 15, and so on, right? So I want to see if there is a relationship, right, between the a student rank, in his high school class, and then the placement score, the placement test score, whatever you want. So to do that, we have two ways. We can either look at the correlation, right, coefficient between the rank and the score. We can also decide to do it visually, right? We can, do a scatter plot between the rank and then the placement score and see how it goes, right? We can have this linear line, this line between the dots, and see if the relationship is linear. If it is, then there is a relationship, right? But if it's a random scatter, then we will say that, oh, there is no relationship between these two variables. So let's try and hit like graphically. Okay, I'm going to come up with a plot here between these two, like a scatter plot. Then afterward we can look at a correlation coefficient, right? We can use a correlation coefficient and see how strong it is, if there is a strong or weak correlation between these two variables. So what I would do here is let me come up with another chunk. Let me insert a chunk, right, and look at the plot. So I want to plot here a relationship between rank, and again I did not attach the variable, so I have to call map placement. Okay, dollar sign rank. So I want to use rank, and again map placement and the score, placement score. Where is it? This variable placement score right here. So I'm gonna plot this, right? Let's give a title to the plot, to make it kind of cosmetic anyway. Main title is main here. Let me call it relationship, okay? Or let me say rank dash placement, okay? Placement, okay? Rank dash placement relationship. Okay, I call it that. I don't know if it makes sense, but anyway, it's fine. What else? Yeah, I want to have a line, okay? I want to have like a B line between like the two graph. So we're gonna have a linear line there, okay? A linear model, linear line. So between map placement, I want to have a linear line. Oh, what's that? Let me take this one out. I want to have a linear line between this tilde and this. the score, right? I want to have a linear line between these two. Okay, cool. So let's look at the plots and what's going on here. Incomplete expression plot, blah blah blah. Why is it saying that? I think I may have missed some. This is 1 2, yeah, definitely. I have to close this, I think. Let's see. Yeah, cool. So that's the relationship, right? And clearly you can see there is no clear relationship here, right? The line looks funny. Clearly you can see this line looks funny, right? Because my daughter, heading here, and then my line is here. There is no relationship. So clearly you can see rank placement relationship. There is no relationship clearly, because when you look at my line, you look at the dot, like there is no match actually, right? Yeah, there is no match. So that's just what I see here. Okay, there is no relationship. And again, we can look at the correlation between the two. So I can run here correlation between this, okay, and this. My placement, data sign, rank. Yeah, I look at the correlation between these two and look at the coefficient. This is 0.56. Well, we do have a negative correlation, right? But it's weak, right? We do have a correlation 0.56. Yeah, it's something, but it's weak. Okay, it's a weak correlation. We do have correlation, very weak. Now when you look at the plot, so that's the coefficient here, that's the correlation here. So again, let me get back to the graph. See, that's how the graph looks like, and clearly you can see the line here. Our line here is heading downward, right? Which tells you that is a negative correlation. And when you look at the dots, they are moving from up there, upper left downward, because clearly you see here this is empty, so they are moving downward kind of, but it's not really strong, right? We cannot actually say, yeah, we see a downward trend, but it's not really strong. So it's not really strong. So which is why the correlation itself is is negative 0.5, right? Yeah, so that's what we can say. We do have a relationship between the two, but it's a weak relationship, right? And the relationship is a downward, which says which implies that the higher the placement score, right, and then the lower the rank. So as you rank higher, it means your placement score goes down. So someone that ranks, let's say 1, like first rank, second rank, so when you are first rank, you tend to have a much higher score, as opposed to someone that has a much higher rank, like someone that the second rank, third rank, fourth rank, they would have a much lower placement score. So that's something like that. So but of course, do not forget, this is not it's not a strong correlation, right? It's a weak one, right? They are not really strongly correlated, but they are by a little bit. So yeah, I'm gonna stop this video here. Thank you for watching, and see you on the next one.